We have learned how to use Hamilton's method, and it may be that when you saw it described, it seemed to you, well, this is sort of the obvious thing to do. It's really a rather straightforward procedure, and I think what many of us might think to do if we were asked to do an apportionment. But let me point out that it has certain defects. And because of that, we're going to learn about alternative methods that have been used called divisor methods. All the other methods we're going to learn are examples of what are called divisor methods. Remember that Hamilton's method was what we called a quota method. That is to say, a method guaranteed to give each state either its standard lower quota or its standard upper quota. I'm going to dwell at length on one of these defects of Hamilton's method, and then I'll mention rather briefly two others at the end. I could expand on the others as well, but I want to look at one in detail just to see some crazy paradoxical behavior. And the paradox that we're going to look at is what's called the Alabama paradox. It was discovered towards the end of the 19th century. There was a lot of wrangling, continued wrangling year after year about how to apportion the U.S. House of Representatives. And in particular, this paradox was unearthed. It happened after the 1880 election. And although any state could have been affected, it turns out it happened for Alabama on this particular occasion. That's the reason we call it the Alabama paradox. I'm going to show you the actual figures from that date. So this is from 1880. There was a census conducted in 1880, and the total apportionment population of the United States at that point was the number shown at the top here, 49 million and somewhat more. Now, I should say, in those days, it wasn't decided what the size of the House was going to be in advance. That would be one of the things that they would wrangle over. That would be one of the things that they would decide. And that's what led to the recognition of this paradox. One of the proposed House sizes after the 1880 election was 299. That is to say, to have 299 seats. Okay, so if that's what you want to do, you just go ahead and apply Hamilton's method. You take the 1880 U.S. population, you divide by this proposed House size of 299, and you'll come up with a standard divisor of 165,122. Now that's much smaller than the standard divisor of today because, of course, it was a much smaller country. It was a country of 49 million, whereas now we have over 300 million people living in the United States. So the standard divisor was much smaller. Now, you take that standard divisor and you divide it into each state's population. Of course, I mean the population at that time. For example, Texas in those days had between 1 and 2 million people. So you do the division as you're supposed to. You come up with the quotas, and there they're listed. And next to them, I've just extracted their fractional parts. Now, the particular 5 that I'm chosen are sort of in the middle of the list because what I'm showing you are states arranged by their fractional parts. Okay, and here we are sort of in the middle of the list. Here we have fractional parts of about 0.6 or 0.7. Okay, so Maryland's fractional part is 0.662, which is larger than Alabama's fractional part, which is 0.646, and so on. Okay, so here are the 5 in the middle of the list. Now, it turns out that if you follow Hamilton's method, you give out the seats initially, and then you start to worry about the leftovers, that you run out of leftover seats when you get to Alabama. Okay, so Maryland does get its extra seat and therefore its upper quota, and the same thing with Alabama, but Illinois just misses out, okay? The line always has to be drawn somewhere in Hamilton's method, and this is where it happens to be drawn. So we said to Alabama, here, you get the last seat, and Illinois is waiting, and we say, nope, no extra seat for Illinois. So, thus far, there doesn't seem to be any paradoxical behavior, but as I said, the size of the House was not fixed in advance. And other people were saying, well, let's try out 300. Okay, so now I'm not showing you the other calculations. I'm just showing you what would happen if you used a population, sorry, not a population, but a house size of 300 seats. Well, now, of course, the standard divisor will be slightly smaller. If we divide by 300 instead of 299, that changes the standard divisor. And then, of course, it changes the quotas slightly. It also then changes the fractional parts. Okay, so here are the fractional parts. Now they're slightly out of order. It turns out that when we do this recalculation, that the list is no longer ordered correctly. They're slightly out of order. And in particular, you'll notice that Illinois has a fractional part that is larger than a fractional part of Maryland or Alabama now. Okay, so now when you go to do the cutoff, it turns out that 3 of these 5 states will get their extra seat. That is to say, they'll get their upper quota. And the 3 that qualify happen to be Maryland, Illinois, and Texas. And then the remaining states with smaller fractional parts do not get their upper quotas. Again, this wouldn't seem to be a problem. The problem comes when you compare the 2 calculations, okay? Look, one is house size 299, the other is house size of 300. And following the rules for the Hamilton apportionment, look what happens to Alabama. If the house size is 299, Alabama gets 8 seats, that is to say it gets its upper quota. But if there were 300 seats, Alabama gets 7. It gets its lower quota, not its upper quota. Now, if you were from Alabama, I think you would be irate at this outcome. Because what happened? The house size increases from 299 to 300. There's an extra seat, but Illinois and Texas gain those seats, and Alabama actually has to lose one. Okay? There's the paradox. Even though the house size has increased, a state has actually lost a seat. And all of this was done according to what seemed to be the very simple and common sense rules laid down by the Hamilton method. That's the problem. That's the Alabama paradox. Now, I said I'd briefly mention a couple of other defects. We could go through these again in detail, although the first one is sort of theoretical. Suppose you increase the population of one state, while all the other populations remain fixed. Amazingly, under Hamilton's method, the state may lose a seat. That seems pretty undesirable. That's called the population paradox. Another thing that may happen is if a new state is admitted into the Union and told, well, this is the number of seats you're supposed to have, well, presumably you'd want to redo the whole apportionment. According to Hamilton, you'd have a few extra seats for the new state, but amazingly what might happen is the number of seats awarded to the already existing states might change. Again, that seems very undesirable and not something that you want to have happen. So all of these reasons sort of contributed to the fact that we no longer use this kind of method. Hamilton's method is no longer used to apportion the House of Representatives.